Um, yeah, I just checked. One of the calendar is missed, so I think it's okay you joining using April 22nd, that one. And for today, we will continues. Um, we'll go through like for some more details, and then for the rest of the time we're going to like execute another one in the lab. So it's the time to just like for observation and just giving you some hints. Okay, so if we execute what kind of content, like where should we doing the process? Okay, and last time where did we stop by is about the virtual files. Okay, so um we're giving like as a basic because the virtual file right here we will like store on the disk related to the system or the software assembly, we remember. So all the malwares like they always target on the Windows registration. Okay, so they will try to manipulate the keys, so they will maybe for like stable or like persistence. So all this content they're going to do, and last time we stop by here and telling you, okay, maybe you get some concept idea. So for the names of different keys, okay. So for the system-wide setting, okay, so will be under local machine, okay. And if there are some user specific, and then it will like under the current user from HKCU, okay. And then okay, excuse me. Okay. So for the file association, then we'll relate to the classes root. So you see the HKCR, and also there's a users and also the current config. So there will be HKCC or HKU right here. This we need to observe. So if you remember, we try to use the static analysis. Okay, so sometimes we try to output, or actually when we're doing the advanced dynamic analysis, so actually we can output all this information. Like we are going to search looking for something if they are going to access to maybe the H key local machine, H key current user, or H key like classes root. So if you find some strings, try to push it into the register, then you know, okay, so they're going to modify. And as well, we say right here, they store all the information like on disk like that. And maybe there are common keys they are used. So if you um able to find it, or sometimes if you see, okay, it under the software and Microsoft Windows like current version 1. Okay, so I would like to use the right here. So just keep it right here, and then what I did, enlarge it. Kind of that same idea. Like when I install the Windows this like OS. Okay, so maybe some of you try to use your Windows account to sign in, and if you remember, if you using install the Windows 11, right? So they request you to sign in the account, okay, using the Microsoft account. But actually, there's a way you can bypass it, so you can like modify. Okay, you can modify the local machine and try to add some folders. Okay, so right here, then you can bypass. And as far as I just give you some hints, actually online is pretty easy, and you can do this way. Or if you try to install the Windows 11, like let's say if you want to update Windows 10 to Windows 11, because no, like Microsoft they're not support. Actually, you are also can change the registry files, okay, and which allows you to bypass the hardware checking. So it's another way to do that. But this one is just the same idea. And right here, I would like to show you, okay, so maybe under the current user right here. So if we go to current user and then we'll go to the Microsoft software, Microsoft and Microsoft right here. And you'll see the next one under Windows current version and one. Okay. Move a little bit. This okay, so you can see it. So if you want to check and following and look at yours, then you can see okay, and Microsoft, and we'll go to Windows, and we will try to get okay, what's the current version? Okay, and what's the one in current version? And right here we will return there's some automatic like launch right here and Microsoft OneDrive, and also right here Zoom it like 64 exe. So there's some we're running right here, and also a local machine. So we can go to local machine and system right here, system and current control set. So system, we can go to current control set, and under what's the surface. So right here, lots of surface are executing right now. So you can explore if we have something like maybe related to network or like some ABS or like the .NET framework, if you know for Windows, ID right here, parameter. Okay, what the possible parameter that will pass it? Okay, and what the management. So all these will be like passing the parameter, and we have one more under the local machine software, Microsoft, under Windows. So you see that under software will be all the applications we install on a VM. Of course, right here will be on a VM, and then can go to Microsoft. We'll search the directory for Windows. So right here will also show all the applications under this part, and we can be looking for current version of like let's say if I want to access audio. Okay, so what the audio is right here, disable, enable. So if the malware try to control yours, they can like just like modify the virtual files, okay, and just go to all this and change the value and modify the values. So if you see something like path where they search for, then you have to pay attention, okay, be aware of it. And also there's a registry like based on persistence, then is including the like app in. Okay, yeah. So this one is with the dynamic link, right? If you remember, so injection. So on the app startup, so once every time you start it, okay, so we modify. Pretty common or basic share experience about the if Google Chrome your homepage like if like they always they modify the Chrome, you may thinking okay I already delete the app, okay, so the application I already like deleted, and sometimes when you delete an application on your Windows system, actually you didn't remove other related like maybe the wishes files, okay, maybe it didn't really delete it. So even you next time we install it, okay, let's say a Chrome you install it because your wishes file already modified, okay, so even you install the new copy and then save it on your maybe a C drive, okay, but they will still load the configuration from the registry file. Okay, so that's why like even though you try to reinstall it, you got the same things, and then maybe they will modify the homepage. So it will happen the same. And also maybe the image like file execution option right here, we say to intercept the binary or binary. So right here. So last time we say like we stop by right here, and we do have some analysis tools we can use to which is repair and or which is tree like explore. So will helping us to look at the arbitrary like feature or like for the deep inspection. Okay, so we can check it. In the exercise, we didn't really show you, but if you are interested, always like open it and try to install it on your VM and check. Okay, so those like pretty maybe you need to see sometimes we change the keys or add the new values or what they try to delete that entries. So right here, when they try to modify, they're always changing the value right here. So you see the D word and then they will change the data. So this is pretty easy to find it. And usually sometimes they will try to create a new one. So you see like create a new key, or if they want to assign some like new values, or like they're using a D word, okay, which is a D word right here. So different type. So here all will be the footprint. So we have to check. And the next part, we will investigate and look into related to the virtual memory. So it gives you because like OS like gives like each process like the illusions like its own full memory space. And in physical memory, so kind of like they will abstract the paging. If you in the operating system, we're talking about like physically we have the physical memory. Okay, but sometimes when we like swap out and doing paging or like store something in the virtual memory, and we use the long time ago, like if you still in hard drive, then of course we create the virtual memory on hard drive. And nowadays we using SSD, like mainly SSD that we will create on our SSD, like the virtual memory. So including that for the memory section, it will have some like function calls. So we handle it some like local variables and also the heap. Okay, that will be dynamically that allocate the data. Okay, so you will see a lot like for stack and heap and code segment. So it like the executable instruction. So you see the text. So when we open the here, I will keep the content. Okay, and then when we output the contents, so you will see maybe the text file and what the data file. So this we going to search for, like if you remember, like we previously using the PE view or the PE Studio. Okay, so that's what we see, and some data segment initial the global constants or like that. That's really research. And those are behavior, so they will mainly they will injecting the payload into the heap or unused that stack space. So that means like if there's some function calls like try to or try to modify the local variables, or when they try to have some data allocated dynamically, then maybe there's something else they're going to inject. Okay, and also they will modify the memory to change the behavior of other processes too. So if you remember the examples, that will be this part, and we will check like when we look at the PE files. Okay, so in the layer of memory, so running process, so they will save it and they will also import. So they are like resolve like through the IAT. So it's called the import address table. So you see, and in the left time, so I will also show to use the PPV Studio and open the file one more time. Okay, but just letting you know, we will look at two files. Like last time we looked at the binary patching, so it just like not really harm compare our previous slide of behavior. Okay, for today, we also look at the content with the NT, and that's a simple one, and open and check it. Okay, so let's continue. And for this, like the candidate, we have some like reflective DLL injection. So this one will load into the memory without touching the disk. So here's the idea, like it's got a reflective and also the process are holding. So it will be some logic process that will replace in memory with the malicious code. This like part if we try to the really good example we did before is about Microsoft. If you remember, so we look at the virtual memory. So by the original one, okay. So when we look it, we create another fake the false one. Okay, the Microsoft error report that one. So it's like kind of like process erroring, same idea. So you can catch it the malware, so they are not really touch the disk. So they by inspecting memory layout. So you see if we don't really execute it, especially if we are analyze that on the memory layout, then most of the time we have to do it in our dynamic analysis, especially in advanced like dynamic analysis. We need to like really looking execute the files and then observe and monitor right here. Of course, we can find those like content, maybe checking where they modify. Okay, so maybe like the process hacker, we using process mon. Okay, so that's the application we need to like check and then see. Okay, and also, we have more tools we can use the dummy to capture the RAM. Okay, or sometimes we can do the snapshot FTK. If you are taking the digital forensic another course, actually we will mention the FTK. Okay, so this one also can be used to snapshot the memory and disk. Okay, and the Winamp PMEM. So this one will be a lightweight, so used for the vulnerabilities content. That means that they are we lost on the RAM, so it's a good. But we need to, like because on the memory, so every time it's more like dynamic. When you execute running, it will store the RAM once it close it, or you shutting down your computer, so they will lost. So that's why, we try to always to do analysis first, like because they may disappear doing but here one thing you need to be careful, because when you try to dump the memory, so because it can be very large, so you need to like face it. So just be careful, because for the memory, including all other application they store on it. Also, in the memory, when you start to load your computer, even the OS, but of course like depends on the region, because some malware they will modify the OS level. Okay, so also maybe if you need to check, okay, maybe the Windows OS, okay, being modified, those like malicious code like injected, then you have to dump the OS copy too. Okay, and right here there are some useful probably you can check, or like PS3, if you in PS3 list, so we can see the running process, or like the list. Okay, so we can find the load DLL, malfunction, and to detect the code injection and CMD scan. The consoles we can recover the command line history. So all these can help us to spotting the malicious injected code. Okay, so some shell code or pack binaries in the memory. Here, of course, we have to have more skills like to search it for it. And in this course, we mainly just look into certain examples, like we just taking some labs, okay, to observe. Actually, for the malware analysis, also requires you even more knowledge on different type of on the OS system, how they really are working. Okay, Actually, with limited time, we cannot really cover like talking about all the Windows systems and all the Linux system because for different OS, we have different ways. So just like for you have a basic understanding because for the system architecture right here, just like we say, okay, if we look at the 32-bit or the 64-bit, so actually they have a different memory access or like register size. So and if we compare to the ARM or nowadays, like if you see maybe if you're using the Apple like M series like the M1, M2, M3, M4, or some IoT devices. Okay, so they're using ARM or some tablet. Okay, so other so the architecture of the CPU they change, then the way okay they execute, then we have to check maybe the user mode, like how do they execute the applications or some like privilege they're using or kernel mode. If you remember the kernel mode execute like between the system drivers or some critical OS function that execute on the kernel mode, and we can try to sometimes you can try to access that in the user mode or in the kernel mode, okay, to modify the experience. If you do have some experience that touch on the Windows or sometimes or like the Mac OS, okay. So sometimes if you have some crash error, then you have to modify. They say, okay, please go to the command line or switch the login using the kernel mode or something like switch from user mode to kernel mode like this, okay. And they will the reason why here because even us we can switch it, that means the malware so it allows so we can try to export the kernel so to avoid the detection, and those like architecture determine how the malware interact with the OS, so we have different way. So as well as say like from here no, even just the architecture using the 32-bit or 64-bit like the ARM in Windows or even the Mac or the Linux, so they will change the way how do they interact, okay. And here this part the next one just recap a little bit about the instruction set architecture ISA, okay. So there's some assembly instruction but I think like most of you took the assembly course before, and there's some like basic operation like move, call, jump, push, pop. Okay, there's some like control flow. They will try to call for functions and return. Okay, RET for return or NLP. So this one for the shell obfuscation. And when we look at, especially we use a lot and actually really highly requires your knowledge on the or like pay attention if you see right here. Because when you observe the all those like this these the code, so you see okay they have move and they will call certain function, especially they if they the malware they need to create a new function, then they will like have a or they will need to get the parameters. Okay, so sometimes they move them from the register to the register storage, and then they will call another function. And once they call another function, they will jump to certain section, okay, and also they will perform like they need to push the parameter. So if you remember, we have the open internet or the function we need to pass the parameter. So you will see they change to the push and certain parameters, okay, and then they once they done, then they can return back, okay. So you will see all these maybe like operations like control, and of course we have different type of registers, okay. The EX EPX I will show you if you remember in the week 9 one, so I just give you some general purpose register. So for the 32-bit, okay, right here we're coming. So when you see what's the EX EPX or if you be doing the dynamic analysis, so the debugger, okay, so when in the debugger you see they pushing the content to the EX or like some like EBX for the base address or some like E6 for the counter, so for the root operation or EDX, so something included for the IO operation. or mainly like stack pointer. We are like in this part because we always see because they point to top of stack, and also the EPB the base pointer. So this one will be the base of the stack frame. So all this, so you will see right here they moving. Okay, so this one is the assembly level, and of course we using a debugger, then open the file when you execute a debugger. And this folder. Okay, so if you remember the debugger, and then let me open it. We should open it. Okay. Okay, comes out. Okay, once you execute, so you will see our debugger, it will like showing what's the value when you okay, it's slightly slow. Okay, so when you try to, let me restart it, and once you execute, so every time what's the value they're pushing in, what's the EBX. Okay, what they're pointing to it, and also maybe the what's the base, and also now when they push it, what's the current like EPP ESP. Okay, and EIP right here. So where they pointing to? So you can refer to it like this. Okay, so you need to have some idea. So where should we look into it? And if we have the like 64 bits, then we have more like RX, RSP, so slightly more. And the reason why you have to learn the assembly or like have some idea, so that's why because we really rely on it, and when we do the reverse engineering, and when we doing this, okay, engineer no matter using debugger, cutters, look at the source code, and it requires you. Okay, and sometimes like when we open it, like especially if we investigate like in the lab, as we say, because we have target, we know those like malware, so it's just like learning behavior. Okay, what's this malware? Okay, we're going to do performance, so we already know like what kind of content we have to search. But if I giving you a brand new, like it's a something new malware, okay, so it's a system, then how can we observe? Then you have to really search by yourself. And there's like the importance of the reverse engineering, because nobody telling you the clue. So you will be the one like looking for something, you think, okay, it looks pretty juicy in this part, then let's pay attention on this session, or like when we execute, then just observe, and then we have to do it several times, repeat several times to observe. And maybe some, of course, like because when we talk about the the register, because they were more dynamic running on the web. Okay, so because some operation they mainly doing on the in the execution, okay, process. Okay, and also we have the portable executable, so it's the PE. Okay, we have the PE format, remember, for the empty drive, so including the DOS header, so those will be legacy, so they use that by the packer. Okay, and also the NT header, so those will be the signature and file metadata. And also we including the optional data, including the what's the entry point or the architecture infos. So they are stay in the like PE. And the sections including the dot text, so it will be the code, and then dot data, so with the initial like the data, and out data, so will be those like constraint imports, so they are stored over there. And also the outside RSRC, so will be those like embedded icon, config, and payloads. So they are all these like stored over there. Okay, so that's why we need to know what's the PE, so they works and help. to identify some unpacking or injected code. So this one you maybe we COVID long time ago we did. Okay, so we try to look in if you remember we use the like pack unpacking that one. So for the pack file, so maybe for the test code data they are really small. Okay, so after they unpack it, then you see, okay, so the the malicious application they will expand more than original one. So these are the way they want to pretend, okay, or avoid the scanning from the antivirus application. So here's the idea. Okay, so here's some key contents we can search for. And we always saying the DLL. So those will be the dynamic language encoding. So they will load at one time. So including to like share their code. So including like user 32 or like kernel 32. You see a lot. Okay, so if you no matter you execute be doing right here. Let me switch back. And if you look at some like source code right here, so sometimes you see a lot like they touch on the kernel 32, okay, or dynamic. So here's a reason why. So they can some like injecting with some like remote thread or like set the Windows a whole EA or reflective DL injection. So we talk about the reflective DL injection. So all these they may know those managers and they are in place. So there's a usage of it. And for the malware like execution like flow, sometimes we always start have the train stuff with initial like vectors. Okay, of course they will start from like phishing exposure or USB. So once you download it, okay, and after that you will like maybe open it. So they will have a we call a dropper. If you remember, the dropper or we call loader. So we place it and launch the payload, the content, and they execute the payload. So those like payload will be the core malicious like functionality like C2 ransomware or keylogger. So those like in the reverse engineering we're doing. So of course lower level. So assembly language you see do they touch on something, and then persistent, do they touch on the virtual file or task or service or some driver? Okay, and we have some like literal like movement extractions, so they are all possible doing this way. And that's why like start the beginning we will do some like packing, okay, and encryptions, authentication, and also how can we do the process holding and injection, and later maybe we will hook those API. So especially those APIs, you remember we test before. So we're looking for those URL and then what's the access to the files. And sometimes they will create new um executable files. So okay, those new executable files we have to investigate. So, okay, so but those we have to really open and execute the file. Okay, those binary file, and then they will create a new one. So we can investigate and look into them. Okay, so it will be the repeating process. So I just summarize everything we talked. So we'll be including the OS internal, so how they the malware integrate in the system, and the virtual file they will touch on it. So will be the persistence or some like footprint. Okay, in the memory area, so maybe we are doing for dynamic analysis, and in the architecture we will analyze mainly sometimes we look at using the PE Studio, like look at those code they execute. Okay, so so far for today, we will open another file. So will be the called the anti-analysis file, and we can open. Let me close everything. Okay, let me close all this. And for today, we will look at the desktop. Okay. So for today, we just look into the called the simple NT analysis. So if you remember for this one, we already know. Okay, so we try to detect it. Okay, is that on the VM? Then if yes, then we are not going to execute anything. For the observation, as our first part, we always got to execute it, and okay, no debugger detected, so they will okay, and then it's okay, good, and then payload is done. Okay, then after executed, let me open the right here. So for this one waiting is so they were just checking if the debugger is a present. Okay, this API call, and of course then let's try because we already executed, and this time let's open our debugger. It takes some time. When also is the time, so for today's exercise, just like open the empty and access this application. So if you have any question, if you want to do, then you can follow me. Okay, and just like look in this source code. So right here, we see nothing, right? So when we open and nothing is executed, and then let me close it. Let me do it one more time. You see, it comes up. Because if you know the debugger behavior, so right here, okay, so if we open the debugger, okay, and then when we try to open the file and then import this executable binary, so it will have a terminal pops up because when we execute, so if something comes up, but this time nothing. Okay, so you may try to follow, and I will use the cutter. Use the cutter right here. Open the screen so I enlarge. So this one is the anti analysis file, and we try to look into these files. There put a lot. Okay, let's go back to dashboard. So as we say, like if we look at the language, so it's using a C purpose, so it's a executable files, and we can like bit 64-bit. Okay, and the class will be PE 32+. And for our static analysis, we also look at the hash. And if you remember the library, so this time the kernel 32 user 32, okay, MSV CLTDL, so will be the dynamic linked list, so will be also used it, okay, and this is like pretty basic. And when we do the string, so it will have some outputs. So basic when we do the we I quickly jump over the previous step, so we say the static analysis. So you can see like under the section, so all the text. Okay, so right here, so we can find maybe the outdated section. Okay, so I see the debugger. Okay, so some smack the and if you remember, there's a pop out, right? So it comes out no debugger detected. Okay, and giving a payload, and then boom. So if we execute it, so you see the obtain all the message right here. So okay, so we know, and then this is most important is debugger present right here. So is that really exists? Then once we found, so if I'm not telling you anything, so when you use the string, like maybe using for a string to output it, so you will see some contents right here. And when you see the strings output content, okay, you see, okay, it touched the kernel 32. They have a calling that is debugger presents right here. And then what's the message? So you think, okay, this really juicy, then let's look into it. So this the major part A. Okay, then we will make the screenshot and then you can put the note and this like where we're going to investigate. So this part is we will do it in the static analysis, right? And after we complete this part, when we move on to dynamic analysis, when we execute, okay, so we really pay attention. Okay, when they receive it, and I'm using like process monitor and you see, or sometimes we check the memories, like what they push in. Okay, and let's like go down. Well, actually, we already got the our major part because for the West, and we once we already detect, okay, so the return value and for the West, not really using, but we can just quickly scan right here. And when you scan that, going down and feeling okay, so it seems not really special like for the West where we like when we try to some under the debug info. So I just go down quickly. So just like scan it. Okay. So you see all this that belongs to debug information. Okay, then maybe no, and then for the rest will be some string under the data domains. Okay, so they're not belongs to here, and then okay, so car is stop by right here. Okay, the string. Okay, so that's mainly the part we are pretty interested, and and for the graph mode, we can like if we switch and then you will see but of this one just the main the quick step, so it's like this and the compiler this part. So yeah, debugger main step. So for this one, and let's go back. So because you see the like is the debugger presents right here. So when we click on this part, so it mainly like when we're passing, so at the page right here. And I to show you the content. Okay, let me the browser. Okay, the debugger. Okay, right here. So you can log into it. Here's the ID. So it's the it returns the boolean. Okay, so actually it's pretty because you know the syntax you're writing in the C purpose and it's a boolean and it's just returning. So if there's a current process there running in the content of a debugger, that they will return a value. So it's a non-zero. So it's not running. So the value is zero, and that's it. Okay, so it doesn't require any like parameter. So if they call this function, okay, so when they call in the HTTP presence function, you will not require to push any parameter. So when you decompile, let me go back. Um, if you look into this part, like when we using the output, so when we call that is like debugger presents right here. So we are not required to pass any parameter. So it can like detect it. Once you get it, then you can print out the message. And that's like mainly for this one. So for the NG analysis, this program is pretty straightforward and it not going to touch anything. So it just like, okay, if you detect it, then I will just put a message and that's it. So not really complicated. For the rest of the time, then you can try to look into this part and Also, maybe if any question, then you may ask. And for the rest, just letting you know, we have like coming for the rest, like also just like for the lab time. So depends on you. You may join it, or I can just pre-record it. So depends on your opinion. So we have coming. Okay, let me get to the link. Let we're going for the West, we just like try to execute and just like open all these files and execute doing some observation. So depends on you. You may try it in this time, or I can pre-record just showing okay how can we like execute. So this one including other files. Okay, some like fishing and that's including okay this Excel, so spreadsheet. Okay, so also we have the Word files right here. Okay, some like work file like the LCX right here. So you can fishing some, and we are that's what we're going to open and see all these files and or like the shell. Okay, if you know the shell code. Okay, so they're quite from memory. So they're using, and also we have the off script. So this is what we're going to look into and open. Okay, and for the rest of time you have your final, because I will let you to you will do current answer as a last part of assignment, because I is the WannaCry. So you have to open it and then answer them question. So you try to execute observe it. Okay. But there are lots of examples. So just like for coming next week, 2 days, the lab just like try to open and show you. So depends on you. You can like join it in the time to see. But most of them just let you to follow, just open it and use all the dynamic analysis to observe what's the behavior. Okay. And for the rest of time will be yours. So if you want to check, then you can follow and look into all this content. Or if you have question, you can feel free to ask question. Okay. 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 So if you are like in the coming lab. So when we look into the files, so it's a like not like the executable files, but for other format type like Excel file, Word files. Okay, but for static analysis, we can always the same. Like we can see about the contents, like maybe including the worksheet. Okay, so maybe some like thing right here, and some like basic content. But compare with the executable file, it will be different. So we have different way to look at it to the data, but when we try to load it, you will see because I everything for the reverse engineering, basically we will like see something like RX, so you know prefer 64-bit, okay, and then they will push it, like some content, and when we loading this session like the ESP, okay, the EAP when we done and return, and all this, and for this one, because it's different from the main file, so we just like showing some static. But for the next one, we will next week we will look into these files more. Okay, and just close right here. So we have the memories. Actually, there's so many tools. Like it may be in the slides I mentioned about it, but we didn't really use them. But they are pretty a lot. There's some really powerful and helpful, which is the and we can use it and check it. Explorer, if you remember the Visual Explorer. Okay, looking at. So maybe the two way here, so we can try to like loading have the live system, so we can check like if they have touched on the if we remember maybe under the user and then over the system software. So what kind of software they change. So that's what we can observe like what's the virtual file they modify. Okay, after and it's loading. And for the rest of time, I will stay here for B. So I will see. So if you are staying right here, then feel free to ask any question or anything if you want to ask. I will wait until maybe if you are leaving. Okay. So far, I see no question, then I will stop the sharing right now. And thank you, and have a good one. Bye.